All right, so here we are in number 6. Let me go through the beginning part again. So we're on, the plan is to finish 12.3 today. So put on the board 12.3 should be due tomorrow. We're supposed to finish it today. So this is what's it called? The geometric sequences, right? The ones where you multiply from term to term instead of adding from term to term. Remember that, what we're talking about? So I gave you the formula last time, and I said it was, what was it? A sub n is A1 times R to the n minus 1, right? So on the exam we take week after next, right? Is that what we're looking at? Yeah, week after next. We're scheduled May 1st and 2nd, so 2 weeks from today. We'll be wrapping up day. That'll be part 2. This exam number 4. So here's the you're going to have an A sub n and an S sub n formula from the last section, and then an A sub n and an S sub n formula from this section. So 2 A sub n's, 2 S sub n formulas. So this A sub n, this is for geometric, which means multiplying or dividing from term to term. Right? The other formula was the last section, arithmetic. All right, it's a geometric sequence. All right, so here's our formula. A sub n is A1. This is A1. They're just calling it A, but it says up here, initial term A. Negative 4 times R, which is 7, to the n minus 1. So there's the general formula, which they're going to ask as their second question. Their first question says, what's A sub 5? Well, I'll just use this formula to find A sub 5. It's negative 4 times 7 to the 5 minus 1. Just plug in a 5 there. So that means it's negative 4 times 7 to the 4th. It's negative 4 times 2401. What it is? We did that yesterday, huh? And then that's some big number. Minus 9604. Is that what it is? 9604. So there's the fifth term. The fifth term is negative 9604. And the general formula, which they're going to ask right after this, is negative 4 times 7 to the n minus 1. Just like that. We good with those? That makes sense on how to do that? So just use this general A sub n formula for any geometric sequence. All right. Let's try. All right, there it is. We're on number 7. I'm on 7? I don't know. Whatever number I'm on. Looks like 7. Try that. Same kind of thing. So find the general formula again, which is A sub n is A1 R to the n minus 1. And then find the fifth term. So find the general formula and the fifth term. Be careful with that R. That R is negative 7. So when you put a negative number to a power, you've got to have parentheses around it when you calculate it. Right? You aware of that? Do you know what I mean? There's a difference between saying negative 7 squared and negative 7 parentheses squared. You guys know there's a difference between those two? Remember that? The top one means 1 negative 2 7s, so negative 49. The bottom one means 2 negative 7s, so positive 49. See the difference? Right? If you don't put parentheses, the minus is not repeated twice. You with me on that? Powers are only on the number. They're not even on the sign, which is kind of weird. They're not even on the sign. It's kind of like the minus is a minus 1 separate. That's kind of what it's like. So if there's no parentheses, the power is only on the 7 and not on the minus. And so it stays minus, right? Everybody see that difference I'm talking about? Well, how do you know which one we want here? Well, what does this formula say? It says R, whatever R is, to the n minus 1 power. What is R? Minus 7. That means the whole R, the entire R. So that means you got to put it in parentheses, right? That means it's A1 negative 5. We don't need parentheses on that because there's no power. Times minus 7 to the n minus. That's the correct formula. It's wrong to write it like this. That's not right. No. Everybody see that difference? Why? What's wrong with this one? Because this one does not mean the entire minus 7 is raised to the minus 1 power. Just the 7. And the minus is an extra. It's like an extra minus 1 sitting here. That's what that really means. And that's not what this formula says. It says all of r. And r is minus 7. All of r raised to the power. See the difference? Okay. So make sure you do that correctly. That little minus stuff messes up a lot of people. So minus 7 to the minus 1 like that. So there's the general formula. And then they want the fifth term. So we plug in a 5. So minus 5 times minus 7 to the 5 minus 1. Minus 5 minus 7 to the 4. Minus 5. And that's the same number we did in 2401 again, huh? That's minus 1205 or something? All right. Minus 1205. There we go. Oh, am I off? 12,005? Off by a spot? Yeah, I guess so, huh? We can't. 5. It can't be, we started with 2,000. It couldn't end up being 1,000, could it? All right, so there we go. Thank you. Questions on that? We good? All right. All right. Same thing. Come up with the general formula. A sub n is A1 r to the n minus 1. Like that. And see if you can simplify it. So A1 is just the A, which is the root of 15. The r is also root of 15, like that, right? So far, so good? Right, A1's root 15, r is root 15. Now, can that be simplified? Yeah, what can we do there? So here's a good place. This is the kind of thing that happens all the time in calculus. You go to Math 5A. This is the kind of thing all the time. That can be simplified. It's actually a very simple algebra rule, which you've all done before. But it just looks weird in this setting. When you put like roots in there and you put like in power letters in the power zone, it's kind of weird and you can tend to forget the basic algebra rule that you know. This is what I mean by calculus is all about knowing algebra really well. Like knowing it deeply. And that's what it'll be about. So let me you might wonder what in the world are you talking about? Like here's the rule I'm talking about. What is like 7 to the 3rd times 7 to the 4th? Remember that rule? What happens when you multiply the same bases? It's 7 to the 7th, right? You add the powers. You know all that rule, right? I'm not giving you a rule. That's exactly the rule about it. So when the bases are the same, what can you do with the powers? Add them. So what if I go 7 times 7 to the 4th? What power's on that first 7, really? So what's the answer? 5th, right? Now, look at this. Those two bases are the same. What power is really on the first one? 1. So what do those powers do? Add, right? Isn't that what they did right here? Same bases multiplied, powers add. That's the algebra rule. Huh. So this is going to be root 15 to the 1 plus n minus 1, better known as n. There it is. Did you follow that? That's the kind of thing you do all the time in calculus. It's really just an algebra rule, but it's fancy. And there's roots and letter powers, but it's the same old rule that we learned in algebra. That's the kind of thing you got to become a master of to make it well through calculus, is all those algebra rules pushed to their limits. All right, so there's the a sub n formula. Now, what's a sub 5? Just plug in a 5 there. Do they want an exact answer, or what do they want? What do they want? Do you know? They didn't say, did they? I bet they want 225 root 15. Right? Isn't that what they want? I'm betting. Now, how do I come up with that? Because, yeah, it's 5 of them, right? So let me write 5 of them. 1, 2, 3, 4, 5. First off, good so far? Fifth power means 5 of them. You can put them in they're in the root. 5, root 15. So you can put them all, I just put them in one big root. You can make them 5 separate roots. It's all the same thing. Doesn't matter. And then remember what roots do? 2 15s in, 1 out. Gone. 2 15s in, another one out. Gone. So 2 15s come out. Remember, roots are a 2-for-1 deal. That's how I always teach it in algebra. 2 in, 1 out. Because there's really a what? A 2 in the hook there. It's a 2 roots, a square root, which means 2 in, 1 out, 2 in, 1 out, right? So out comes 15 times 15 with another 15 staying inside, huh? When you simplify that, and that's 225 root 15. Like that. That good on that? There's the answer they want. Questions on that one? Little weird, little plain. All right, so we have 3 3/5, 3/25, da, da, da. They want the 6th term, and that's all they want. Can you tell what's happening from term to term here? Yeah, multiplying by a 5th or dividing by 5, it's 2 ways of saying the same thing. Does that make sense? Right? They took the 3 and they divided it by 5. And then they took this and they divided by another 5. Or they multiplied the bottom by 5 if you want. Same thing. Multiplying the bottom is the same as dividing. Do you realize that? That's the same thing, right? So really they're just multiplying, right? Because this was 3 over 1 if you want, right? And they multiplied the bottom by 5, then by another 5. So can you tell me what the next, this is the first, second, third. Can you tell me what the 4th term is going to be? Yeah, just use your calculator. It's 3 and then another 5, huh? 125, just times 5 on that bottom, right? And can you tell me what the 5th term is going to be? 625, they just did times 5 again. And can you tell me what the 6th term is going to be? Is it 3125? So and that's what they wanted, and we're done. That's what I would do instead of messing with the formula. You know, if they asked me to go all the way to the 73rd term, then yeah, it'd be worth it to do the formula instead of, going all the way out to. But if they're just asking for like the 5th or the 6th term, I think it's easier just to do it by hand like that. And that's what they'll almost always do in this section, because the terms get so big, so fat, or so small, I guess, as the case may be. So big or so small, right, the denominator gets so big, so fast that they're not going to ask you to go far down the line, because it would just get crazy big. So they're only going to ask you for, a short distance. You might as well just do it by hand real quick, save a little time. So, make sense on that? Just keep doing the next step. What's the difference between this section and the last, the one you just did for homework? What's different what's happening in the jump from term to term? It's geometric, right? And so what does that mean is happening from term to term? Multiplied or divided, huh? Whereas the last section, we were adding or subtracting from term to term. That was called the arithmetic sequences, huh? Yeah. So I would here's the first, second, third. Go ahead and find the 4th and the 5th. Just look at the pattern, what's being done, and just do it 2 more times. And you'll have what they're asking you for, the 5th term. So what's being done every time? How do you make 3 into minus 15? Times -5, huh? Times -5. Times, every time they're multiplying by -5, aren't they? So, is that 350 and 375? Is it minus 375? Is that right? Did I do that right? Okay, and then I can't do the next one. 1875 positive? 18. So there it is. There's the 5th term. We got it. Good enough? Just follow the pattern there. Math. Math is, what is math? If you were to say, what is math? I don't want to get too philosophical, but math is basically the science of patterns. That's pretty much what everybody who does math higher up says. The math is patterns. That's it. Math is patterns. Well, do you see the pattern there? Do you see the pattern? So we have 0.6. Let me give a little more room. We have 0.6, 0.06, 0.006. This is the first term, the second term, the third term. And they want me to go all the way down to the 10th, right? They're saying find the 10th term. The thing math does for you is it enables you to see a pattern and thus do something big quickly and easily. That's math, basically. You know, by observing patterns, we can make big jumps. Can I jump all the way to the 10th term? I don't want to do all the ones in between. I just want to follow the pattern. Yeah. So the first term has one thing after the decimal. There's a lot of ways you could say this. The second has two numbers. The third has three numbers. Or you could say it has one less zero than the number. That's another way to say it, right? Or if you count that zero, I can say it's the same amount of zeros. There's all kinds of ways you can say it that are true. You know, you might say, third one, 3 zeros, including the zero in the front. Second one, 2 zeros. First one, just 1 zero. All right, that'll work. So 10th term, 10 zeros, including the zero in the front, I mean. So the 10th one is going to have a zero in the front, and 1, 2, 3, 4, 5, 6, 7, 8, 9, right? There's 9 zeros here, right? One more zero there. So 10 zeros altogether, and a 6. That's got to be the 10th term by just following the pattern, huh? Much easier than doing them all the way out or some formula thing. That's it. That's it. That's what math is all about. Math is about patterns, right? And we, human beings who have logical minds, can think and follow patterns. Animals cannot. In spite of all the talk of animal intelligence, beavers are still building the same kind of dams they were building 2,000 years ago. But humans follow patterns. All right. Let's try that one. 4, 12, 36, 108. So they just want the formula. Yeah, remember the formula is A sub n is A1 R to the n minus 1. All right, so basically they just want me to stick the A1 in there, and the R in there. That's all they want me to do. So what's the A sub 1? What does A sub 1 always mean in all these formulas? First term, yeah. That's just the 4. Okay. What's the R then? Because that's what goes there.
The ratio.
Yeah, the ratio. Meaning the jump. That means ratio or the jump. Like what's making it jump from term to... How does 4 become 12 and 12 become 36? Times 3, huh? Done. Good there. What's the other way you can always find a ratio? Now, this one we could just see it, without doing anything tricky. But sometimes in a minute again they're going to get ugly, give us ugly ones. What's the way we can find the ratio when it's hard to just spot it? You just take second term divided by first term. That'll give you the ratio also, right? 12 over 4. See, that'll tell you the 3 also. We could tell it was 3 without being so formal. But in a minute it's going to get uglier, and we'll want to use this little trick now. Just take second term divided, any term divided by the previous term will tell you what the ratio is. And that's where we get the word ratio. Okay. I don't want to skip any, but then I'm forced to skip the hard ones. All right. So, can you do that one? The first spot goes A1. So what's A1? Yeah, that's just that -2 that's just first term. Now, can you tell what's happening from term to term? It's putting an extra 5 on the bottom, meaning a 1/5, huh? But it's also changing sign. Did you notice that? Negative, positive, negative, positive. What makes that happen? It's multiplying by a negative, huh? So the R is -1/5. Does that make sense on that? Right, because if you take -2 and you multiply it by -1/5, you get positive 2/5, which is indeed the second term, and on you go. Multiplying by negative. And if you were ever enough said. Let's see. Okay, so they're giving me the 6th term, and they're giving me the R. And they want the general formula, huh? The A sub n formula, and what's the A sub n formula? It's A1 times R to the minus 1. So I've got the R. All I really need is the A1. You with me? I've got the R like that, right? Just pop that in right there. So I've got the R, but what I don't have is the A sub 1. How am I going to get the A sub 1? How do we solve for it?
Plug in A6.
Oh yeah, we could. We could. Yeah, plug in. Yeah, because yeah, right. Because we have a sub n. Yeah, so plug in 6. A6. So a sub 6. Plug in a 6. Good idea. 6, and that's minus 243. So minus 243 is a1 times minus 3 to the 5th, like that. Does that make sense what we did there? Let's plug in a 6, and then we can solve that. Yeah, good idea. I was going to do something different, but this is probably a better idea. The minus 3 to the 5th, 243. Is it negative 243? Oh, so a1 is just going to be 1. So then divided by minus 243. A1 is just 1. So then the formula they want, a sub n is 1 times minus 3 to the n minus 1. There's the formula. Good. Good thought. Questions on that one? All right, so they're giving me a sub 2 is 9. I don't know a sub 3, and a sub 4 is 1764. What do y'all think? How are we going to do this one? So you know what we need, right? We need the a sub n formula. A1 times R to the minus 1. Yeah, what are we going to do? Any ideas? Let me give you a hint this way. Something was done to the 9 to become this. I don't know what. Call it R. Multiplied by the ratio, whatever that is. And then they multiplied by the R again. Times R, and it became that. You with me? So they took the 9, they multiplied by R again, and they got 1764. Isn't that true? Right? Because that's 2 jumps down the line. That's whatever the R is, whatever they're multiplying by every time, they did it twice. Times R, and 9 times R became the 1764, huh? 14. So that means 9R squared is 1764, huh? Makes sense? Solve for R. Divide by 9, yeah. R squared will be, what is that? 14. Is it, what is this? 196. 196, right. Then we root it and it's 14, huh? Yeah, then we just root it and 14, yeah. See how we came up with that? We're not quite done yet. We got the R. We're almost done. We got the R. So it's going times 14. So this must be whatever, 90 and 36, must be 126, and then times 14, that must be 1764. Good. Last thing, now we got the R. The R is 14. So we've almost got the formula. The formula is A1. All we need now is A1 times 14 to the n minus 1. A1, how do you find A1? Yeah, just go backwards. Just say A1, somehow A1 times 14 became A2. Whatever A1 is, times 14 became the 9, right? So I'll try to run it out of room a little bit, but let me put it over here. A1, whatever it is, times 14 became 9. Does that make sense how I came up with that little equation? Am I going too quick? Am I losing you? Does that make sense? So I found the whole trick is realizing the R is what's being multiplied every time, right? And so I started off by saying, okay, 9 times R became 1764. So 9R squared became 1764. Solve for R. R is 14. And then I backtracked. A1, whatever it is, times 14 becomes 9. A1 times 14 becomes 9. Divide both sides by 14. A1 must be 9/14. Is that good? A1 is 9/14. So what's my formula then? Coming over here. Let's wrap it up. Am I on the screen? So AN is A1 R to the n minus 1. So AN is A1. 9/14 times R, which is 14 to the n minus 1. There we go. So that was a little trickery there, huh? Questions on that one? All right. Notice now between them there's plus signs, right? See how there's no longer commas? It's kind of a subtle thing. You got to kind of be intentional to see it. See how we have plus signs now? So plus, no, I was going to write sing. Plus signs in the middle mean S sub n, not A sub n. So now we're shifting. So just like in the last section, we had A sub n when there was commas between them. S sub n when there's plus signs. Same thing in this section. A sub n commas, S sub n plus signs. So this is going to, they're adding them up now. They're not just listing them with commas. They're saying, hey, what do they all add up to be? That's a little different, right? So now we want to know the S sub n formula. What is the S sub? I never can remember it. Here, I got it in my notes here. It's A1, I'll give you this right in the test, 1 minus r to the n over 1 minus r. So there's the S sub n formula for geometric. So remember, we had an S sub n formula in the last section for arithmetic. Now we have one for geometric. So there it is. I'll put all 4 of those right at the top of the exam week after next. You don't even have to put them on your 3x5 cards. They'll be right at the top. You can see them on the practice exam number 4. Okay, so here we go. A1, what's A sub 1? That's the 1/9. That's always just the first term. Huh? So that's right here. A1, so that's 1/9. What's the R? Let me give everybody a chance to think. Think in your own mind for a second. Nobody say it out loud. Give everybody a chance. Look at that list. This is the thing that gets people. So let me give you a chance. Don't say it out loud. Give everybody a chance to think about it. What is the R? You know the R, that's the ratio. It's what's being multiplied every time, causing the jump from term to term. Right? Look real close at that R for the R. So what is the R? It's just 3. It's not the 9. It has nothing to do with the 9. Why not? Because the 9 isn't part of a change. Right? The R is what's causing a change. The 9's just sitting there. It's been there all along. How does 1/9 become 3/9? You multiply the top by 3. Has nothing to do with the 9 that makes 1/9 into 3/9, right? But that's a mistake I see a lot on tests and stuff. People do something with the 9. So we're just looking at change, remember? And also, this is where, since they get a little more tricky, if you're at all unsure, how can you find the R? What's the way to find the R? Second term over first term, remember? So if you're at all unsure, just say, look, it's 3/9 over 1/9, whatever that is. 3/9 over 1/9, second term over first term. And then how do you do a fraction over fraction, remember? The bottom one flips up like a high diver going upside down. Comes up here, becomes 9 over 1. 9's cancel. 3 over 1, just 3. So sure enough, the ratio, what's being done every time, is just multiplying by another 3, right? So the R is 3. So it's 1 minus 3 to the n over 1 minus 3. Why are they're kind of putting it in a funny format, aren't they? Complete the sum. Maybe I'm confused. I am confused. Let's see. Type an integer or some other function. Complete the sum of the sequence. Complete the sum. Yeah, I can do it, but we're going to have to, we're almost there. It's too bad. I won't make you do all that in the test. Yeah, let's do it. I'll show you what they're saying. We're good. That's all good. I just need some more space. That's all true. Okay. So this really is the right answer on a test. I'll give you full credit for that answer. That's a fine answer. But they want me to put it in a certain format. This format they're listing right here. So how do I do that? Well, I got to do a little cleanup. So here we go. 1 minus 3 to the n over minus 2. Good with that so far. Again, I don't care about that stuff on the test. I'm fine if you just want to leave this. So minus 2. Now, you think, is that what they want? No. See how they want? They want like a number here. And then they want a number to the n and a minus 1. I have to make this look like that, unfortunately, because Math Excel is being kind of picky here. So how do I do that? Well, you got to get this guy over next to this guy. So that'll be minus 1/18. Good so far? See what I just did? That's the same thing. I just put those two denominators. I just multiplied the, I just did top times top and bottom times bottom, basically. Right? Is that good so far? Now it almost looks like, I'm kind of scribbling, it almost looks like this. But what's left to do? I need a number in the front. I got a number in the front, minus 1/18. But then I need something to the n, minus 1. I have it vice versa. Can I switch it around like that? Because that's what they want, huh? They want the n in the front here like that. Can I do that? Yeah, if you change the sign in the front. There's the answer they want. That's the same. Do you realize those two are the same? Do you know if you switch the order of things subtracted, it just has a negative effect? Do you know that? You ever stayed up late at night thinking about that? 7 minus, whoops, I'm kind of scribbling there. Think about if you have 7 minus 3 versus 3 minus 7. They're both some kind of a 4, but that one's a negative 4. You see, if you switch the order of subtraction, it just changes the sign. That's all it does. So when I go from this to this, I just got to change the sign in the front. And nothing else has really changed. So it took a little bit of work to give it the look they wanted. 1/18, 3 to the n minus 1. I'm going to go type that in, make sure they're... So questions on that? Is that okay then? A little manipulation they wanted at the end. So again, on a test, this is fine with me right here. That's fine. Just use the main formula, plug in the A1 and the R. I'm happy. I don't require any particular format. Okay, so you know what that big Greek S is, right? Stands for sum. Whenever we see the Greek S, we know we're going to use Estevan. All right, you know the Estevan formula. I just gave it to you. A1 times 1 minus R to the n over 1 minus R. So they're making me do, now they're putting the n at the back. It's like they just keep changing their mind, the format they want, huh? Now they're putting it at the back. Okay, so they want that format. When they give me this symbolism, I'm just going to do k as 1. Let me just find the first term. It means you're going to take that formula, 2/7, and plug in a 1. So that's just 2/7, right? How about k is 2? That would be 2/7 squared, which is 4/49. We good so far? And, on it goes, right? So remember what the big Greek S means. It means take whatever formula, plug in 1, plug in 2, plug in 3, right? All right. So we did a couple of them. You just do a couple. That's good enough for now. Now, do we have the Esteban formula? What's A1? It's 2/7 is A1, first term, right? 2/7, we good? And now we just need R. It's really all you need is A1 and R. Can you tell me what R is?
2/7.
Yeah, good. How do we find R officially? See, it's getting a little uglier here now, isn't it? How do you find R? Second term over first term. Remember, R is a ratio. So take the second term, 4/49 over the first term, 2/7. Some of you can just see it's 2/7, and that's great. If you can just see it, you're right. If you're not sure, if you're at all unsure, then just put second term over first term. That'll tell you the ratio. Take this guy and flip it up like a high diver, upside down, like that. So it's 4/49 times 7/2. 7 goes into 49 2 times. 2 goes into 4 2 times. It is indeed 2/7. So just multiplying by another 2/7. A1 is 2/7, and the ratio is also 2/7. So just multiplying by another 2/7 every time. So this is 2/7 to the n over 2/7. Now, again, on a test, that's great. Full credit. That's a fine answer. But they want me to put it in a certain look for Math Excel, so I'm going to have to fiddle with it a little bit. Are we good to there so far? Can I erase that stuff on the right, that R? You guys got that copied down? Okay, because now I need to find, I got to make it look like they want it to look. They're being kind of painful, tedious today. So, okay, so I've got to make this look like this. In other words, I can only have a 1 minus thing. So you've got to basically calculate that bottom. What is 1 minus 2/7? What's a whole pie? Take away 2/7 of a pie. 5/7 of a pie. Right? You have a whole pie and you take away 2/7 of it, you got 5/7. So what do we have? We have 2/7. Well, I better bring it up here. We need a couple steps. So I have 2/7 times 1 minus 2/7 to the n over 5/7. So far, so good? Now, this is a fraction in the bottom of a fraction. What do we learn to do? You flip it up like a high diver going upside down, right? Now, you can flip it up to the right, which is normally what we do, or you can put it on the left. You know which multiplying, it doesn't matter left or right. When two things are times, it doesn't matter what order. I want to put it this way because I want it to interact with that guy. Just because that's the look they're making me go for. Again, on a test, I don't care about any of this. So 2/7 times 7/5 times 1 minus 2/7 to the n. Good, see what happened? See how that 5/7 went right up here, upside down, right there? And now cancel 2/5, 1 minus 2/7 to the n. There we go. That's the look they want, which is the same as this, just a little cleaner. Is that okay? A little fancy moving things around there? All right, I'm starting to read the writing on the wall. I'm not sure I'm going to make it through this section. I'm only halfway through with 10 minutes to go here. All right, yeah, these are long. We might need another day or half a day on this. All right, so Estevan formula. See why we're doing Estevan again? There's not commas between them. There's pluses and minuses. So we're summing them or adding negative, same thing, right? So it's Estevan, not Estevan, right? Estevan is for commas, just listing them. Estevan is when you're adding them all up, even if they're negative. Sum. All right, so it's A1, 1 minus r to the n over 1 minus r. That's what they want. What's A1? -1, it's always the first term. There it is. Here comes the r. The r is always the hard part. What's the r? Can you tell? Yeah, it's got to be 13. Remember how you do the r? The r is always second term over first term. So it's what? Minus 13. Use the sign over the signs in the front matter, right? So r is 13. Plain positive 13, regular 13, right? So 13 to the n over 13. They probably are not going to let you on a test. Again, I'm fine. That's fine. Just type that in. I'm good. But they probably want you to clean it up a little bit. So I'm going to make this minus 12 on the bottom there, right? Good so far? Can I make this minus 12 to the n up there on the top? Is this that? No. Is everybody okay with that? You can't subtract on the top because that 13 has an n on it, which is different than a 12 with an n on it. You can't subtract those on the top, but on the bottom you can. Right? Okay, now what? Now put these guys together. It's minus 1 over minus 12. Like that, right? And those two minuses become plus. There it is. There's the way they're going to want you to type the answer in. Is that good? Is that okay? So I'm just always grabbing the denominator and putting it over here, huh? You see that pattern? It's pretty much what I'm always doing. Questions? It's a harder section. All right, so choose the sum. Sum means I'm using the Estevan formula, right? When they say sum, I'm using the Estevan formula. Okay, so let's use that. They want me to actually compute a number this time. So, here we go. What's A1? 1/9. We good so far? What is R? It's 7. Huh? You getting good where you can just kind of spot it? See the R7? If you're not sure, I'll do the formalities again. Second term over first term. Second term is 7/9. First term is 1/9. Flip this guy up. 9 over 1. 9's cancel. 7 over 1. R is 7, huh? It's just multiplying by another 7 every time on the top, isn't it? So 7 to the n over 1 minus 7. Good to there. So there's the Estevan formula. Now they want you to actually compute it. Here, let me make that a minus 6 on the bottom there now. Good to there. And then you could put these guys together. 1 over minus 54. Like that. That good? Now, they're wanting an actual like final answer. How do I get an actual final answer? I got to take this and plug the n value into it. What is n? Careful. Careful. Look at that. Look at that series. What is n? I mean, remember in all these formulas, in these last two sections, what is n always? Number of terms. Remember? A1's the first term, AN's the last term, n is the number of terms. Remember how that always is? It continues to be in all these formulas. N is the number of terms. I called it the ordinal, like second or seventh, right? It's the ordering. So basically we're asking, how many terms are here? That's what n is. Careful. Careful. How many terms are there? Not 12. 13. Do you see that? How do you know? Because this is 1, 2, 3, 12. So there's 12 from there to there, and one more makes 13 terms. Huh? Got to be a little careful. 13 terms. N is 13. So take this little formula. 1 over negative 54. 1 minus 7 to the 13. Hit the buttons on your calculator, and it's going to be one of those four answers over there. Anybody got which one it is? It's this one? So make sure you can get that on your calculator. A couple people getting that? More than one? Yeah, okay, good. So if you have any trouble with that, grab me here in 5 minutes. I'll be glad to help you with the calculator. Make sure you can take that and get this on your calculator. Make sense how we did that? All right, so they're giving me the sigma notation. So S sub n, of course, S sub n is A1, 1 minus r to the n over 1 minus r. All right, so whenever they give you, you notice what I do, whenever they give you that Greek sigma notation, I always do the first couple of terms, right? Just to make sure I know what I'm actually looking at. So I'll go ahead and do n equals 1 and n equals 2. Just the first two is probably all you need. So the first one's going to be 4/7 to the 1 power, which is just 4/7. And the second one's going to be 4/7 squared, which is 16/49. So there's the first term and the second term. And that also allows me to get r, right? Because r is always second term over first term. So it's 16/49 over 4/7. Flip this guy up. 7, 4, multiply. So r is 16/49 times 7, 4. 7 goes into 49 7 times. 4 goes into 16 4 times. R is 4/7. R is 4/7. And what's A1? It's also 4/7. Everything is 4/7. So S sub n is 4/7 times 1 minus 4/7. We're getting kind of scribbly there. Four sevenths. Good to there? Now, we got to plug in. They want an actual answer rounded to 3 decimal places. So they want me to come up with an actual answer to that thing. How am I going to do that? Can I clean this up? You good? You're going to have to plug in. What's the n? Well, actually, let me first do the kind of cleanup I usually do. What is 1 minus 4/7? What's a whole pi? Take away 4/7 of a pi. 3/7 of a pi. And then that's going to flip up right there, upside down, right? You getting real comfortable with that maneuver? It's going to be times 7/3. Like that. Good to there so far? And then these guys cancel. So 4/3, 1 minus 4/7 to the n. Good to there? Now plug in the n. What's the n again? How many? N is number of terms. And clearly 15 terms. Right? If you go from 1 to 15, you've done 15 terms. So n is 15. Plug that in right there. So 4/3, 1 minus 4/7 to the 15. So hit the buttons on your calculator for that, and you should get an answer. Somebody got it rounded to 3 decimal places?
Yeah,
1.333? Anybody else getting that? Okay. That must be it. Is that good? Oh, look at that. We're out of time. We only got 21. I can't believe it. We didn't get 2/3 of the way through. That's a long section. All right, so ignore the information on the board.